Hi and welcome to this new tutorial. In this tutorial we're going to talk about SPI. As you're going to see, we're going to take the same approach we did with user peripheral, and so let's dive into it. So the first thing, as we did with user peripheral, we're going to do the high level initialization, then a low level in MSP.c, and then we're going to test the code. So this is exercise, so you need another board. In this case you also need an Arduino. I'm going to use an Arduino 1, so you're going to need an STM board. I'm going to use the Nucleo F446, and you also need an Arduino to send the data. Otherwise you can use other tools like a logic analyzer or an oscilloscope. It will also work. So let's first create a project here. You need to go to AZ, you need to go to SPI. We're going to use SPI 2, like so. You need to find peripheral and you need to activate. We're going to use the transmit all in master because we're going to just send data. You also need to do other configuration with it in the other video, so you already know how to do it. So I already created the project. This is here, SPI exercise, and this is basically the code. I just already written most of the code so that I can explain you better. You also need to delete the rest of the files and create mnc.c, msp.c that is now empty, and it.c, and that is actually useart. We don't need it, you can just remove it. id.c is basically empty, and in msp.c we just have this file we used also in the last lectures. So let's come here, and as you know, the first thing is to initialize the HAL APIs. Then in the last sections we did the UART init. In this case we need to do the SPI 2 initialization, so I created this function. So let's go to this function, like so. It's already configured. As you know, the first thing you need to do is the instance. This which APIs, which SPI peripheral you're gonna want to use, SPI 1, SPI 2, SPI 3. In this case we're gonna go for SPI 2. Then just type the name of the structure variable and init. So I also declared up here the structure variable. I don't need this. SPI handle type def. So we have user handle type def and also SPI handle type def. So I wrote H stands for handle, then SPI the name the peripheral, and then to the number. In this case number 2. So the mode, as I said, we're gonna use the SPI's master. So this is the one that sends the data and directs the communication. The direction is just one line because we're gonna just send the data. We don't want to, it's not a full duplex, we're not gonna receive any data. And data size is the default one, 8-bit. The polarity low, face one edge, these are actually doesn't make a difference and any difference. So we have NSS. This is for if we have another slave. In this case we want to use NSS soft so that they can communicate with the slave. And the baud rate pre-scalar we're gonna set for 8 so that it produces a specific clock. We're gonna talk more about the clock in the next lessons. And then we have the first bit. This is actually not so important. And time mode disable, let's disable this, and these are actually other values. I could also not use these things. Here I just do the HAL SPI initialization as we did in the last times by checking if the initialization went okay. Otherwise you're gonna go for the error handler. This is just a while loop. And other thing we need to do is initialize the button, like so, because we're gonna send the data when the button is pressed. And so I created the GPIO init type def. I enabled the clock of the GPIO I'm gonna use for the button. So this is your user button. If you don't know what is the button, what is the number, the pin, have a look of your user manual to find out this. So I'm gonna initialize the button that stays in the port C. And in this case, so we did the first 3 steps. Then we need to send some data. So to send some data, you actually need to do as we did with the useart data. user data, as the user data we sent last time. We also need to calculate the length, and then we need first we need to check the button is pressed. Actually, I created a function that I don't use. I don't use this function because I already do this check here. Let me remove this function. So I created this function, but I think it's better just to create this code here, so just a line of code instead of a function. And what we are doing here, we are reading the pin. We are checking if the GPIO port number C number 13 has a value. If it has a value, it means that the button is not pressed. We just need to wait until it's pressed, that it will go out of this loop. Then, as you know, there is a phenomenon that is known as button debouncing. To solve this problem, we need just some delay. This will give some delay of 200 milliseconds. Then we can send the data with SPI. Let's focus on this later. So now let's move on. So to configure these values in SPI init, you can just, as we also did in the last lecture, we can just refer to the alternate function mode and just look for SPI. This is SPI 1, SPI 2, and you'll find these values. You can use these values. So this is what I did here. I'm not going to explain every detail, but I'm basically enable the clock for SPI 2 because I'm enabling the clock for the peripheral, then also for the pins, the ports required. Then I'm gonna configure. So if you're using SPI peripheral, you need to configure MOSI, the MISO, the 0 clock, and also the NSS pin. So the MOSI is master output slave input. We actually not gonna use the MISO, so I could remove it. This is for the master input, the slave output. Since I'm just sending data to Arduino, we're not receiving anything back. I could also remove this. But, the serial clock is what actually governs the communications. So important, and you can also find details here. The serial clock, just look for it like so. Serial clock. The NSS is important for slave communication, with master and slave communication. So just configure these values, and now we can get back to our function. As I said, we're gonna first transmit the length of the data we're gonna send, and then we're gonna send the real data. So in this case, we're gonna first send it the data, the length. And then in this case, it is the address of this variable, is the length. This is how transmitting the length. And in polling mode, now we're gonna transmit the actual data. In the resources of this lesson, I also attached the code you're gonna use in the Arduino, so just use it in the Arduino Ide. So I'm gonna open my Arduino Ide, and here it is. This is the code we're gonna use. So this is the pins you need to look for. So these are, you need to connect the MISO we configured here. So this was our MISO here, port C number 1. And you need to connect the port C number 1 to the pin number 12 of your Arduino one. I'm not sure if this code will work for other Arduinos. If you have other Arduinos, just adapt this code to your Arduino. And the serial clock is this one, and the MOSI is this one. So I'd actually not use this MOSI, but just for reference. And the SS pin, slave select pin, is number 10. So just make your connections. So in a nutshell, this is the way you need to make the connections. So pause the video now if you need it. After we made our connections, let's check if the SPI communication is working. Let's press the user button, and as we can see, we are getting the data, so it is working.